Okay, section 13.1 is called Counting Principles. It's all about how many ways you can order different objects, different books, different items of clothing, different routes to a different city. So 13.1 is all about just kind of learning how to count up the different ways without actually counting them all up. And then later in the chapter we'll get into two other things when it kind of matters the way you order objects. In this section it doesn't really matter what order you grab things in. So take a look at this first example here. It says, suppose three towns, Anna Maria Island, Bradenton, and Longboat Key are in a way, so that two roads connect Bradenton and Anna Maria, three roads connect Anna Maria to Longboat. How many different routes can one take to travel from Bradenton to Longboat through Anna Maria? So if you look at this picture here, it's kind of a little directional thing. If I go from Bradenton B to Anna Maria, I could take road P or road Q. Then to get from Anna Maria to Longboat, I could take roads X, Y, or Z. So if I do this picture over here now, you can kind of see it all laid out. So for instance, here would be Route 1. Bradenton over road P to Anna Maria, then road X to Longboat. Or, what if I went Bradenton, take same road P, but then I take Y to Longboat, or P to Z. So then here are my three different routes to get from Bradenton to Anna Maria using road P. And then if you do the same thing using road Q this time, here are my three routes to get from Bradenton to Anna Maria, then to Longboat using road Q to start with. So, take a look at it. How many do I have? Three here, total of six, excuse me, 6 different routes to get there. Now, if you're thinking about it, it doesn't always make sense to draw out a big picture like we did in that one. So here's the fundamental counting principle. Pretty much what it says. If you're doing two different things, two different events, maybe you're taking roads, maybe you're choosing items at a restaurant, articles of clothing, two different things. The way you figure it out is that you take the first number of things times the second number of things, and that's your total number of options. So if we look at the example we just did, roads P and Q, I had 2 options, times roads X, Y, and Z, I had 3 options. That also gives me my total of 6 without drawing out all the roads. So let's try a pretty easy example. Example 1. You're at Outback. You have 5 different types of steaks, 6 different types of sides. How many different steak and side possibilities are there? So, using the fundamental counting principle, we just take our 5 types of steaks times our 6 types of sides. We get 30 different options. Right? Not so bad. Okay? Then let's take a look at this next example. All right, this one's going to be just slightly different. In Florida, license plates display 3 letters followed by 3 digits. How many plates are possible if repetition of letters, so you can repeat A 3 times or B 3 times, if repetition of letters, part A is allowed and part B is not allowed? Okay, so here's what I usually do with this. If I know there are going to be 6 different things on the plate, okay, you don't need to do these little dashes, but it's kind of neat for the first few. 6 different things. And I have 3 letters to start with, then 3 digits. So, if I'm allowed to repeat letters, for the first option, I have 26 letters in the alphabet, which gives me 26 options. Okay? I'm allowed to use that same letter on the next one, so I still have 26 options. Then I'm allowed to use it again on the third one, 26 options. Okay, now, digits. Digits include 0 through 9, so there are still 10 total digits. So I can use a digit, same, I'm allowed to repeat it, allowed to repeat it. Crank all those through the calculator, and here are all the possible numbers we could get. 17,576,000 total different types of license plates. Okay, alright, now take a look at part B, just slightly different. So, I still have my 6 spots, but you cannot repeat letters or digits. Actually, wait a minute. It says just letters. Excuse me. Just letters. So, for the first letter, I have 26 options. So let's say I choose letter A. Then for the next one, I've already chosen A. I can't use it again. This time, I'm going to use B, or B or another letter. So I'm down to 25. Then I'm down to 24. Now, it doesn't say anything about digits being repeated, so I still get this 10, 10, 10 for digits. And then what the fundamental counting principle says is you multiply all those out, and here we go. Now we're down to 15 million. So there are fewer possible plates if I am not allowed to repeat letters. Okay, so pretty much the back side of this is just seeing different types of orderings of these things and how different questions can look. So why don't you guys try example 3 on your own? Okay, same idea, 3-letter words, words in quotes, because they don't actually have to make words. So for part A, for example, you're just going to have 3 spots, and repetition is allowed in A and not allowed in B. So give that one a shot. Okay, now let's take a look at example 4. Slightly different. 8 horses in a race. How many different orders are possible for completing the race? So if you think about it, 8 spots. Okay, 1, 2, 3, 4, 5, 6, 7, one more, 8. Okay, for first place, how many different horses do we have available to us? Well, we've got 8. Okay, and then the horse comes in first. So for second place, now we're down to 7 choices, then 6, then 5, then 4, then 3, then 2, then 1. So I'm using all 8 horses. Now, that's known as a factorial when you go from 8 all the way down to 1. So it's written like this. And I'll show you that number in your calculator tomorrow. So leave it like that for now, and then we'll fill in the number on the calculator so I can show you where that button is. Now this next example, same thing, horses in a race. This one's asking how many different ways can only first, second, and third be decided. Okay, and we're assuming there's no tie here. So for the first place, still, I have 8 horses to choose from. Second place, I'm down to 7. Third place, I'm down to 6. So you're only doing those first 3. Okay, and what we get there is 336. Okay. All right, example 5. Telephone numbers consist of 7 digits. Okay, 1, 2, 3, 4, 5, 6, 7 digits. The first digit cannot be 0 or 1. How many different telephone numbers are possible? Okay, so the first digit can't be 0 or 1, so that takes away 2 possibilities. So for the very first digit of the telephone number, I only have 8 choices. Now it says nothing about repetition, so when it doesn't say anything, that means that repetition could be allowed. So we're going to put in, for all the other spots, all of our 10s here. Okay, and again, right on the calculator, we should end up with 8 million for this one. Okay, and you can do things in scientific notation if you like, but that's okay, just putting a few zeros on the end there. All right, the last one. We're going to talk a lot about birth order combinations later on in the chapter, but for this example, it says in a family of 4 children. All right, so 4 children, 1, 2, 3, 4. How many different boy-girl birth order combinations are possible? And birth order means if you have 3 boys in a row and then a girl, that is different from 2 boys, a girl, and then a boy. If that makes any sense, I can talk about that again. But pretty much here's what's happening. If I have 2 choices, right, a boy is one choice, a girl is another choice, for each of my 4 children, and obviously I'm allowed to repeat because you could have different numbers of girls and boys, it would look something like this. So 16 different possible birth orders.